Hi, good morning. Welcome to grade 9 physics. Today we are continuing the same lesson motion. Don't worry, we will finish it, okay? Today we are going to take the part 6 of that one. If you have not watched the previous videos, please visit my Facebook page, Behrin Tutor, and watch the videos because it's a continuous portion. If you don't know the previous portion, it will be very difficult for you to follow the lesson. So today it is not numerical. I think it is compared to your lower classes. So it is a new kind of. You have done this one in maths a lot, but I think in physics you are doing this one first time. Okay, don't worry. Whatever things you are learning in maths, surely it will come to physics. So let's get into our topics. Today's topic is about graph. Okay, what is the use of this graph? Why we use graph? Graphs are actually pictorial representation of some data. Suppose you have so many data, you have a data of some 10 years, 20 years or something, and you have to have a look at uh, in a very short space or something, or you want to predict what, according to the trend, you have to predict what will happen after this year or something like that. In that case, graph is very good. Okay, so the graph, but for us actually we are not dealing with this kind of long time data and all. For us the graph is something different, but interpretation of graph is a is an essential skill for science students, but we have only limited number of graphs, but it is very important. Okay, so today we have to study three kinds of graphs here. The first one is distance time graph, second one is velocity time graph, and the third one is acceleration time graph. We are going to deal with each one separately because together it is very difficult to deal with them. So first let's go for distance time graph. Okay, so we are going to study distance time graph today. So you have some basics in graph, how to draw a graph, what are the things you have to make sure that when you are plotting a graph. And so let's have first, I just want to revise how to draw a graph. Okay, so graph, of course, we have, usually we use a graph which is having two axes. Which are the two axes? This one is x-axis, this one is y-axis, and we plot some physical quantities over here, any quantities in x-axis and y-axis. So normally when we are plotting an xy graph, we are trying to say how y varies with x. Okay, how y varies with x. Now, normally in all the motion graph, time will be one factor. We are observing an object. As time passes, what happens to the object? What happens to its speed? What happens to its distance? What happens to its acceleration? These are the things we are observing in the lesson motion. So all the time for this particular lesson, in x-axis, we will plot time. Okay, so in x-axis we are going to plot time. Make sure that when you are writing that one, please write unit in bracket. Okay, so time is our independent variable. Okay, that term is not used in your textbook, but that's the correct word we are supposed to use. Okay, then we are going to check how distance is going to change with time. Okay, so here we will plot distance. So this time on x-axis and distance on y-axis. Okay, this is the convention we are going to follow in this particular lesson. Okay, now then this is our origin. Now we know that this is our origin. Oh, because we always need a reference. Now, suppose it is a velocity time graph or a speed time graph, the time will remain on the x-axis. The one which is going to change is on y-axis. If it is a velocity time graph, instead of distance, please plot velocity. If it is an acceleration time graph, instead of distance, plot accelerate or label there as acceleration. Okay. So I am going to take distance time graph in three different sections. Okay. The first one, the object is at rest. The second one, when the object is in uniform motion. The third one, when the object is in non-uniform motion. Okay, so let's take the first one, when the object is at rest. Now the object is at rest. when the object is at rest, what will be the nature of the graph? What kind of a graph you will get as a distance time graph? What kind of a graph means, what we mean is that you will get a straight line graph, a curved graph, a parabolic graph, something like that. Okay, so rest. What do you mean by rest? An object is not moving. So we need some data for plotting the graph. So I need time and I need distance. Okay, I am going to observe an object which is at rest. For example, I am sitting here. There is a table near to me. I am going to check the position of this table at regular intervals. Okay, so these are the intervals I am taking. So where 0 means when I start my observation. When I started my observation, the table is 1 meter away from me. I label it as 1 meter. After 1 second, okay, I checked 1 second. Again, the table is not moving, still there. 1 meter. After 2 seconds, again I checked. Same place, 1 meter. 1 meter, 1 meter. So after this observation, I will conclude that the object is at rest. Okay. Actually we don't need this set of observation. Okay, we can simply say the object is at rest. But just to bring little more drama in this portion, we are including like this. So 0, 1 meter. Like so the time is changing, but the position of the object is not changing. So we will consider that the object is at rest. Okay, now I am going to plot the graph. Okay, 0, 1, 2, 3, 4, 5. Luckily, I observed till 5 seconds. So I can finish there. Okay, now I am going to check this one. Okay, so 0.25 meter, 0.5 meter, 0.75 meter, 1 meter. Okay, so at that when time was 0, when I observed the table was in the same place. Where was the table? 1 meter. The table was here at 1 meter. After 1 second, still the same place. 2 still here. 3 still here. 4 still here. 5 also here. 0, 1, 2, 3, 4, 5. Everywhere same. So how I will draw the graph connecting all these points, I will draw a graph like this. So this is the nature of distance time graph for an object which is at rest. How we will suppose you cannot tell like when teacher it is a sleeping line like that you cannot describe the nature of the graph. What you will tell? It is a straight line parallel to x-axis. That is what we have to tell. Some students when we are asking questions they will stand that it is like this. No. For exam, you cannot show like that. You have to describe how it looks like. Okay. So how you will describe the graph? Of course, it is a straight line. It is a straight line and straight line. So straight line can be different type. Okay, I can draw a straight line like this also. Like this is also a straight line. Is it like that? No. So you should be a little more specific. So it is a straight line parallel to whom? Parallel to time axis or x axis. You can write. This is how we have to. The thing is that you, when you after learning velocity time graph, when we are teaching distance time graph for the students, they will be okay with that. When the next section velocity time graph comes, they will get confused. One of the confusion is this one, distance time graph. In an object at rest means whenever you are looking at the object's position is not changing. That is why it is considered as an object at rest. So when you plot a graph, look here, after 1 second, same place, 2 seconds, same place, like that you have to check it. Okay, so I think this is clear. So how to describe the graph? It is a straight line parallel to x-axis. So our first one is done. First kind of distance graph is finished. Okay, the object is at rest or the object is not moving, the object is stationary. These are the words you can use for this one. Now let's move to the second category of distance time graph, when the object is in uniform motion or uniform speed. Okay, so I have a different set of observations with me for this one. Look at the observation here. The observation. So what I am going to do now, I am going to explain which one? Uniform. Is it uniform speed? Uniform motion, uniform speed or velocity also same we can write. Okay, so uniform speed, how we will conclude that the object is at uniform speed? Look at this observation I got when I started the observation. This is the distance. That means it was just close to me, no distance. I am measuring the distance from me. Okay, so it was very close. After 1 second, it traveled 4 meter. After 2 seconds, he is 8 meter away from me. After 3 seconds, he is 12 meter away from me. After 4 seconds, it is 16 meter away from me. So I can see that the object is moving away from me, but with same, he covers same distance in equal intervals of time. In all 1 second, I can see that the object is covering 4 meter. 4 like that in each time interval. Like for every 1 second, he covers 4 meter. That is fixed. There is no change in that one. That is called uniform speed. Okay. So what will be the velocity in this case? 4 meter. So this is the distance he is covering in how much time? 1 second. So 4 meter per second is the velocity or the speed of the object. So this kind of motion is called uniform motion. The object is moving with uniform speed or uniform velocity. Okay. Now let's plot the graph. Plotting of graph will I don't think that it will come for you people, but uh, without plotting makes a little more sense for that one. Okay, you will understand the things a little more clearly when you get the data, you plot it. Okay, you can experience that. So this is my origin, this is my x-axis, this is my y-axis. Please label these ones. Okay, it doesn't make any difference, but that's the way. Time in second, label the axis as distance in meter. Okay, so write the unit also. That is also very important. Okay, follow that one because that makes life science little more arranged, organized. Now I have to plot. Okay, 1, 2, 3, 4, 5. Now here, how I will take? Okay, 4, 8, 12. No, yeah, 4, 8, 12, then who else? 16 is there. Okay. If you have a graph paper, you can plot it a little more accurately. Then for 0, okay, I'm starting from here. I'll use a different color now. Okay, so I'm starting from here, and after 1 second here, after 2 second here, after 3 second, where is he? This is stone, so it will be somewhere over here. After 5 second, is somewhere here. Okay, so I made the points. I think you know the graph, how to plot x and y. Now for making graph, I will do, I can see some students leave the marking like that for the teachers to finish. Okay, there is not the way, so just connect it. Okay, take your ruler, connect it like this. Okay, mine is not coming straight line. Okay, this one is not coming. I am keeping in straight line. Okay, so when you are exactly when you do the graph paper, you will get it. Okay, don't worry, you will get sure. I am assuring you that you will get. Okay, so you will get a straight line. Straight line is enough for this group. Of course, it's a straight line. Okay, then what else you can write? A straight line graph start from origin. Okay, we can use little more adjectives for the graph. It's a straight line. Sure, one more adjective starting from origin. Then anything else? Inclined to x-axis. Right now it is standing like this. It's inclined to x-axis, or you can tell that it is making an angle with x-axis. These are the way we have to describe. Okay, so uniform speed or uniform motion happens when an object covers equal distance in equal intervals of time. So if you are plotting a graph for uniform motion, you will get a straight line graph. What kind of a straight line graph? This is a graph or proportion. Like they increases proportionally. Each 1 second 4. Each 1 second 4. So that's the proportionally they are increasing. Okay. So you will get a straight line graph. It is inclined to x-axis, or you can write it is starting from origin, or these are the adjectives you can use for the graphs. That means you have, when you see a graph, you have to say whether it is a object at rest, or it is an object in uniform motion, or it is an object in non-uniform motion. Okay. Now, so we finished rest, we finish uniform motion. Now the third one, non-uniform speed. Okay. So as the word says, the non-uniform means the object covers unequal distance in equal intervals of time. Okay. Just have a look at this one. This is non-uniform speed or non-uniform velocity. Non-uniform speed. Okay. In non-uniform speed, you can say 0, 0, 1, 1. Look here, he increased only 1 meter, but suddenly now here it became 3, here became 1, here become 2. That means there is the speed, this distance is increasing, but there is no regular. It depends upon the environment. Okay. So sometimes we will feel to walk fast, sometimes we will feel to walk slowly. So it depends. Okay. So this is normal, our kind of behavior, non-uniform then speed or non-uniform motion, where the object covers unequal distances in equal intervals of time. Here you can see that for every 1 second, sometimes the object covers 3, depending upon the mood, he covers 3, sometimes he covers 1, here he covers 2. So it is non-uniform. There is no uniformity in this behavior. Okay. Now let's draw a graph for that one. Yeah, we can plot over here. Okay, this is the graph I am going to plot. Okay, this is the graph I am going to plot, like y, x, time, second, then yeah, distance, which 1 meter. Okay, this plotting is little 0, 1, 2, 3, 4, like 1, 2, 3, 4, 5. Too much is there. Okay, I am not going to plot all. Can let me take another color. Okay, because too much pink. I even okay. Then 0, 0. Yeah. Then 1, 1. Okay. Then 2, 4 means 2, 4 means it comes somewhere over here. Okay. 3 become 5, like that. When you are drawing the graph, this one is not a straight line. Okay, so you can do a free hand drawing like this. It will come almost like curve. Graph is not coming. I'm very poor at drawing. Okay, why this one? Why this? Oh my god. Okay, the graph is coming like this. So this is a graph which is curved in nature. Okay, that means the distance is increasing, but there is no regularity. So this is a curved graph. Okay, so this one is not straight line. It is having a curve like this. It is going like this. Okay, so this is the graph. Three kind of graph: object at rest, object at uniform motion, object is in uniform motion. Okay, I think it is clear for you. Now let's see some different kinds of, now this is your question. Okay, this is your question. You have to label this one. Okay, the first one, second one, third one. First one is what? The object is at rest. Second one, uniform speed. Then non-uniform speed. Okay, so for exam it can be asked like that, just shape or something is asked, you can, there is no need of plotting. Usually plotting is not coming, so usually like instead of this one, when you see the graph, you see, observe the graph, you have to you have to identify whether it is a rest or the object is in uniform motion or non-uniform motion or non-uniform speed. I think it is very clear for you. Okay. Now let's move to the next one. Mm, this graph also, we know that the plotting is done very perfectly, not like my graph. This graph is a very good graph. Okay. Now what are the other uses of this graph? Distance time graph. What are the uses? This you can identify the motion of the object, whether the object is in rest or uniform. That is one advantage, of course. What is the second advantage? Okay, second advantage is that we can calculate the velocity or speed of an object using a distance time graph. Again, in this lesson, we are taking velocity and speed in the same sense because we are dealing with straight line motions. Okay, so we can use a distance time graph for calculating speed or velocity. Okay. Otherwise, also suppose you have distance and time, you can easily calculate speed or velocity. How you will calculate? You will take distance divided by time and you can calculate it. Okay, from the graph, how we will calculate? Suppose I have a graph like this. This is normally for you, it will come for uniform motion, so don't worry about the kind of graph. Okay, suppose you have a graph like this. You have a graph like this, and from the figure itself, from the graph itself, it is very clear that this is a uniform motion graph. I want to calculate the speed of the object. So speed of the object remains the same. So everywhere it will be the same. What you have to do is that you have, once you have plotted a graph like that, take any 2 points on the graph. For example, I am going to take this point and this point. Okay. Better you take a point where which is you already marked. Okay, because it is an easy way. Otherwise, you can take it will work for everything. But in if suppose I am taking a point in between them, I will get 3.5. So the calculation is a little complicated. So that's why I'm telling you to take the point. Take the points you already marked. Better. Take any 2 points on the line. This is your line, your straight line. So take any 2 points. Draw perpendicular towards x-axis and y-axis, or draw straight line. From that particular point, draw lines towards, from both the lines, draw line towards x-axis and y-axis. Okay, so this is the point I got here. This is the point I got here. Then this one, take the difference in time over here. How much is the distance in time over here? Here I one line landed on 3, the other line landed on 4. So what is the difference? Difference is 1 second. Look at this side. One is on 30, the other line is on 40. So what is the difference? 10. Okay, so how I will calculate this velocity or speed? Well, distance divided by, that means if I am taking this point as x1, this point as x2, this 30 as y1 and this 40 as y2, then speed or velocity v is equal to, always remember it is distance divided by time. So distance is plotted on y-axis, so y should come in numerator. Okay, y should come up, distance. Okay, so how I will do? Y2 minus y1 divided by x2 minus x1. That will give you velocity. It is not complicated as the equation shows. Okay, so what you have to do? Take any 2 points. Suppose I am taking 2 points like this. Take any 2 points. Draw trace line towards x-axis and y-axis. Okay, mark it as x1, x2, y1, y2, then y2 minus y1 divided by x2 minus x1 will give you velocity. Okay, this is how we will calculate velocity or speed from the distance time graph. Suppose the question is that what are the uses of distance time graph? The first one, you can identify the nature of the state of object, whether it is in rest or it is in uniform motion or it is non-uniform motion. Okay, the second one, you can calculate the velocity of the object using this one. So there is some other name for this one. It is not given in the textbook, but I am telling you that this is you have to learn this one. We can use another term for this one, that is called slope or gradient. That is a better word for this one. This type of like, suppose you have a graph and you are uh, taking y by x, and this term is called slope or gradient. That I don't think that it is there in the textbook, but please remember the word slope or gradient. That means, in short, you can tell that slope of gradient of a distance time graph will give you velocity or speed. It is nothing but, as I told, take any point on the any 2 points on the line, go to make straight lines from x-axis towards x-axis and y-axis. Take the difference of x, take the difference of y, then y by x will give you the slope or gradient. So this is the use. Okay. So we finished that one also. I have one more thing to share. So this is a combination. Okay. Look, you can see many kinds of graph here. Look at the first two, this one, first one, and then look at the second one. Okay, both are, by looking at the shape of the graph, you can conclude that both represent uniform motion. One first graph and the second graph. But if the graph is coming like this, okay, this is distance time graph. If you are getting two lines like this, A and B, and you are asked to find out which is faster, A is faster, okay, because this is more steep, or this is more towards y-axis. That's why, that means in a short time it covers more distance, that's why its speed is more. Okay, so if you don't have to give an explanation, and by looking at the graph you can tell this one is fast, or this is fast steady speed, this is slow steady speed. How we will identify if a graph like this is more towards y-axis, that shows it is having more speeds. Gradient will be more. Okay. Green line shows fast, steady speed moving from 0 to 100 in 5 seconds. Look, this one is also using 5 seconds, but in within 5 seconds it is covering only 40 meters. That means it is very slow, but both are steady speed. Okay. Now look at this portion of this graph where I am drawing. This is mean, look at compare with the time axis, this one is not changing the position. That means it is stopped. For example, you, from this is your home, from the home you visited a shop. You are doing shopping there. You are standing in the shop. So uh, we will consider that now you are at rest. Okay, now you purchase something and you are coming back to your home. Okay, so steady speed, this shows that, don't think that speed is decreasing or something. It is steady speed, but he is returning back to its start position. Okay, so if the graph is coming like this, distance time graph, steady speed moving, at rest, speed is 0. Steady speed returning back to the original place. Okay. In this one, you can see that the displacement will be 0. Now, this one, this kind of a graph. Look, if the graph is like this, if the curve is like this, it is accelerating. If instead of that one, if the curve is like this, it is decelerating. Like this, it is accelerating. Like this, it is decelerating. Okay. So these are the thing. The blue line shows the journey with a stop and return to the starting position. The red line shows, so here there is distance. Distance is how much? 40 plus 40, 80, but displacement is equal to 0 because he returned back to his place. Now, the same way you can calculate the speed, take any 2 points. Suppose I want to calculate speed of this one, take any 2 point or towards x-axis, lines towards x-axis, line towards y-axis, and find out the difference. Divide them, you will get the speed. The red line shows a journey starting 2 seconds after, later than the other. Look here, the starting, he started 2 seconds later. That means didn't start from 0. He started from 2 seconds with an initial acceleration, then a deceleration. Like means if it is non-uniform speed, that means the speed is changing. The object speed is not the same at all the point. That means the object is accelerating. So you can conclude that if you are getting a distance time graph like this, that means this shows non-uniform speed. If it is non-uniform speed, this is acceleration. Okay. Now let's conclude everything once again. I'm coming back to which diagram. Yeah, this time. Look at this diagram. Rest, uniform speed, non-uniform speed, or you can write acceleration. Okay, it is an acceleration. So if you are asked to draw a distance time graph, sketch a distance time graph that shows accelerated motion, you can write like this. If it is for constant speed, you can draw this one. If the speed is zero or the object is at rest, you can draw this one. Okay, so they all you have, the thing is that after getting an idea you have to process it yourself, then only you will get a clear idea about what is going on. So when somebody is explaining, maybe you will get the idea, but the thing is that you have to process it, especially for graph. That part is very important. Okay, so we learned about distance time graph for a object at rest, with distance time graph for uniform motion where the object is having a uniform speed or constant speed, how to calculate speed from a distance time graph. Take any 2 points, draw perpendiculars and take the difference in y-axis divided by the difference in x-axis. Then non-uniform speed or acceleration means what? Acceleration where the speed is not the constant. This object covers an equal distance in equal intervals of that time. That means the speed is changing. When speed changes, the object is accelerating. Okay. First, you are clear with these things, like how we will plot a graph, how by looking at the graph, how we will find out the quantity is changing. Velocity time graph will be easy for you. So please go to the portion again and uh, try to learn it again. Look, this is the portion given in your textbook. There is a table for distance time graph. If you want, you can plot in a graph, and it is always better. Okay, normally we don't do that one. But using a graph paper, now you have time, so you take a graph paper, you have some data given here in page number 104. Use the data, plot a graph and try to find out. Okay, that will be good and you will get a better understanding of the things. Okay, so this is it for today. So next class we will come with velocity time graph. Take care. Bye.